Now, this video discusses about how we can solve the exponential equations by reducing them to quadratic equations. So, how should we have that kind of a case? So, we should have to understand that the quadratic equation, it is the equation that follows the order of, ax squared plus bx and plus c is equal to 0. So this is what we call as the quadratic equation. And the quadratic equation can be solved using several methods. We have what we call as the factor method, and we also have what we call as quadratic formula. We call it as the quadratic formula. That is, we can also use as well. And we also have what we call as the completing square method. So these are the methods that are being used to actually solve the quadratic equations. So completing square method. And of course, other than this, we also have what we call as the graph method. So that is also another method we can use to solve the quadratic equations. And basically, if we are entitled to. But of all these methods, the first method to check should be the factor method. That's I would say the easiest method to use. Otherwise, whichever the method here, it becomes the same actual answer. By now, you should have to understand about solving actually the quadratic equations. And in case you are not aware about this, just have to check. Just have to go through my video playlist on the YouTube channel, Facebook, as well as the TikTok. You come across all these things. That is. So in this case, you should have to get that and understand. And also, in order to solve the actually exponential equations that are reduced to quadratic equations, you should also have to be much aware about this. According to the laws of indices, if we have x to the power ma, you should have to understand that this is the same as x to the power m, times n. And it is also the same as having it as x to the power n times n. And this is what we call it as, the power product law of indices. So in case you wonder more about the laws of indices, just have to go through my videos and you'll come across it. Now, let's think of the following problems and see how we can make it up. Let's say we have, and also before we go further, you should also have to understand about the law of indices, like this one as well. If we have, let's say, x to the power m and times x to the power, let's say, y, and keep in mind that this is the same as x to the power m, plus y, since the bases are the same. So which means even the derivation is also possible as well. Let's think of having this. Let's say if we have x to the power, let's say, should be 6 plus 2y. You should have to understand that this is the same as having it as x to the power 6, times, x to the power 2y. And also keep in mind that having this one, it is also the same as having it as, x. It is also the same as having it as, x to the power 6, times x to the power should be 2, and times x to the power 6. Should be x to the power y, by the way, you should have that. And this is according to the laws of indices that we have recently discussed about. By the way, here should be not like that, but we should have it as times y, like that. And also this is the same as x to the power 6, times, and that should be x to the power, y and times 2 outside. So it is the same as that. So any sort of reverse can also be possible as well. And also the other laws of indices that we discussed about, you should also be, familiarize yourselves with. Now, let's say we have the equation which is given as 2 to the power 2x, and let's say minus 3 and that times 2, let's say, to the power x plus 2, and that should be that, and that plus 32, which is equal to 0. So how do you think we can have to solve this equation? So this is an exponential equation, so we need to solve that one by reducing this one to what we get as the quadratic equation. So we should have to understand that the quadratic equation, it is the equation with the form given as ax squared, plus bx and plus c is equal to 0. So how should we transform this to this? So that's the principle behind. So first thing, you should have to consider the exponents that are available in the equation. So we have this case and also this case as well. Then we should have to decide between this and this, which one is complex. So between this one and this one, which one is complex? And also you should have to decide which one you can have to express, and you should have to decide which one you can have to express to have an overall power as 2 in order to meet this condition. And also you should have to look at the bases. We have base 2 and also we have the base 2 here. So which means those bases will still be the way they are. They cannot be actually reduced to be in any other way you can think of. So let's apply the laws of indices here, the law of the indices at this point. You should have to understand that in this case, this is the same as 2 to the power x. 2 to the power x, that should be 2 to the power x, and that times 2. And which is minus 3 times. So in this case, according to the laws of indices, this is the same as 2 to the power x, times 2 to the power 2, and that plus 32. So keep that in mind. So you should have to understand that you should not have to confuse between the way we have done it here and also the way we have done it here. Because the thing is that, if we have x to the power mn, in this case the powers are multiplying. And they are multiplying with respect to the same thing. So in this case, we'll have it as, x to the power m, and it times the powers in that way. While if we have, let's say, x to the power m plus n, so in this case, the powers are adding. So which means the basis of this, it is x to the power m, times x to the power n. That is also according to the laws of indices. So make sure that you are well oriented with these actually laws of indices to avoid sort of confusions. So in this case, we have obtained the actually same components. We have 2 to the power x and also 2 to the power x. So in this case, we have 2 to the power x, to the power 2 minus c. And what is 2 to the power 2? We have it as 4. And 4 times 3, we have negative 12. And times 2 to the power x, plus 32, which is equal to 0. So we should have to rate 2 to the power x to be whichever the variable of our interest. So in this case, we'll have m is equal to 2 to the power x. So which means we'll have it as m to the power 2 and minus 12 m and plus 32, and which is equal to 0. Then how should we have to solve for m there? So in this case, let's think of using the factor method if it gonna work. So the factor method work, you have it as m squared, minus 6m and minus 6m as well, and plus 32, and that should be not be about 6, and that should be, so have 8 times 4, that is m squared minus 4m minus 8m, and that plus 32, that which is equal to 0. So have to pair up this and also pair up this as well. So in that case, we'll have it as, what is the common factor here? So have m and m plus 4, and we'll have, what is the common factor here? We'll have it as negative 8. So have It should be negative here, not plus, should be negative somewhere here. And we'll have negative 8, so have m minus, there should be 4, which is equal to 0. In this case we'll have it as m minus 4, and that times it should be 8 minus, should be m minus 8. So have m minus 8, which is equal to 0. So on that point, then what we can have is now to solve for m. We have m is equal to 4, and also m is equal to 8. Now these are the actually values of m that we have, but our equation, it is in form of x, so we'll have to turn back into x. So we'll have to substitute m here. So in that case we'll have 4 is equal to 2 to the power x. Then how should you solve for x here? So in this case we have the bases, we have base 4 and the base 2. So the lowest possible base we can express to is to have base 2. So in this case we'll have 4 to have base 2. So have 2 to the power 2, which is 2 to the power x. So since the bases are the same, we'll have x is equal to 2. So that is the solution. And also for this one as well, we also have it as 8 is equal to 2 to the power x. So in this point we can express 8 to have base 2, which is 2 to the power 3, which is equal to the power x. So since the bases are the same, we'll have x equal to 3. So that is the solution, as you can see there. And how about, let's say, if we have this another case as well. Let's say if we have 2 to the power 2x, and let's say minus 5 to the power 2x should be 5 times 2 to the power x, and plus 4, which is equal to 0. How should you have the solution for this? So using the laws of indices, we'll have to express this one to have an overall power as 2. So have 2 to the power x, and which is times 2, minus 5, we have 2 to the power x, have it as plus 4, which is equal to 0. Then we'll have to let this to be some variable for interest. Let's think of using y, so have y is equal to 2 to the power x. Then we'll have it as y to the power 2 minus 5 times y, and plus 4, which is equal to 0. The factor method work here. So have y squared minus y, and there should be minus 4y, and plus 4, which is equal to 0. So by now you should be much aware about solving quadratic equations in terms of the methods used. So factor method, computing square method, and also quadratic formula. That's all. So in this case we'll have it as y into y minus 1, that is, and what is the common factor here? We'll have it as negative 4, y minus 1, which is equal to 0. So have y minus 1 times should be y minus 4, which is equal to 0. At this point we'll have y is equal to 1 and y is equal to 4, that is. Then we'll substitute back here for x. So have 1 is equal to, that should be 2 to the power x. So at this point we'll have to express 1 to have the base 2, and that will be given as 2 to the power 0, which is equal to 2 to the power x. So in this case x will be given as 0. And also back for y as 4, we'll have 4 is equal to 2 to the power x, and of which 4 can be expressed to have power 2. Should be base 2, have it as 2 to the power 2, which is 2 to the power x. So at this point x will be given as 2. So those are the solutions for x. We have x as 0 and also x as 2. So that's the principle behind solving exponential equations that can be reduced to quadratic formula. It should be quadratic equation rather. And try to have the following at your own times. Let's say if we have 32 and add to the power, let's say y minus 1, and let's say plus 2, and times, let's say 3 y minus 1, and which is equal to 1. and also try that. And also you should have to try this one as well. 5 to the power 2x, then the minus 6 times 5 let's say to the power x, and the plus 5, which is equal to 0. And also try this one as well at your own time. That is let's say 9 to the power x plus, and let's say 3 to the power 2x, and the minus 1, which is equal to 53. So try those at your own time, and wherever you come across as something to actually difficult, you just have to tell me and we'll discuss over that. And I try to have that one. Thank you.